Hi there, it's Mrs. Bracy, and this is your Unit 8 video notes on systems of equations and inequalities. We are going to be talking today about how to solve a system of equations graphically and how to solve a system of linear inequalities graphically. So we're doing graphing. Systems of equations, hopefully you remember from last year, a system just implies that there's more than one equation. Okay, so if we're graphing, that means you're just going to be graphing more than one equation. So we've learned this year how to graph lines and how to graph parabolas. And so you'll see throughout the unit that you might have two lines or a line and a parabola, and that those are usually the combinations that we see. We're going to stick with lines at the beginning of the unit. So we're going to start with a system of linear equations. Okay, we're going to do this by solving both equations for y, and then graphing the first line and then graphing the second line. I did put on here to use a table, or you can use M and B. Okay, so you can use the table or you can use the slope and the y-intercept, which is what we're going to do today because most of you won't have a calculator to generate a table from. And then we're going to find the point of intersection. So if you can kind of picture what it would look like if you graphed two lines together, most of the time they'll intersect and we're going to find the point where they intersect. So let's start with the equation y equals 2x plus 3. Okay, so let's go ahead and graph y equals 2x plus 3. So the slope of this line, you got to think back to when you learned about lines. The slope of the line is, do you remember? It's going to be 2 because that's in front of the x. We're going to write it as 2 over 1 because remember that's rise over run. And the y-intercept of this line is the constant, which is 3. We always begin at b. So we're going to plot 3 on the y-axis, and then we're going to use the slope to rise and run to get more points. We're going to rise 2, run 1 from this point. Rise 2, run 1. Now I don't have room to do that again, so I'm going to reverse it. I'm going to go back to my original point. I'm going to go down 2, and since I'm reversing it, I have to go left 1. Okay, hopefully this is sounding familiar. I'm going to keep doing that until I have all the points I can plot. Now if this is not the way you want to graph, you can use your calculator to help you graph, and we'll talk about that in class. We just don't have a graphing calculator right now. So I'm going to grab a ruler, connect the points, and here's my line. Okay, you should remember this from earlier in the year. I shouldn't really have to review this much more than that. Okay, all right, next we're going to graph the line y plus x equals 0. Okay, so this time y is not alone. So we're going to start by getting y alone, and we're going to do that by subtracting x on each side. So now we have y equals negative x, and you can put a plus 0 at the end if you want, but you don't have to. So this line has a slope of, what's the number in front of x? It would be negative 1. We're going to make it negative 1 over 1. And this line has a y-intercept of 0. So if there's not a constant at the end, then it's 0. If you wrote plus 0, then you can see that it's 0. So we're going to graph this line by plotting the b. The b is 0, so we're going to plot a point at the origin. And the slope is down 1 over 1. So we're going to rise negative 1 and run positive 1. That means down 1 to the right 1. We're going to do that as many times as we can. And we're going to reverse it. So up 1, left 1. And you can see right there, I just plotted the point where the two lines cross. So that's going to help me in a minute here. And as I finish plotting my points, I can go ahead and graph my line. Always put arrows on the ends. Always label with the original equation. Okay. And there you have a system of equations graphed together. And so again, what we want to do is find the point of intersection. Okay, so we're going to find and label the point of intersection. So it's right here. And that's the solution to the system. So I always want you to say solution and then give me the coordinates of that point. And the coordinates of that point are negative 1, 1. So the solution to this system is negative 1, 1. Okay, so we graph two lines, find the point where they cross, and we have a solution. Now we're going to graph a system of inequalities, okay, down at the bottom here. Your calculator is going to be very handy when you're graphing a system of inequalities, but for today I'm going to show you how to do it without your calculator. Okay, so first we're going to get y alone for both equations. And then when we graph the lines, we have to consider what kind of line should be drawn and which way we should shade. And that information is up here. If the line should be dotted if the symbols are less than or greater than, and the line should be solid if it's less than or equal to or greater than or equal to. So the line underneath makes it solid. And then you have to decide if you're going to shade above the line or below the line, depending on if you have greater than or less than. Okay, let's start with y is less than x plus 2. Okay, so we're going to do the same thing here. The slope is 1 over 1, and the y-intercept is 2. And we're going to use those points to plot the graph. So we're going to plot a point on the y-intercept at 2, and we're going to rise 1, run 1. Okay, rise 1, run 1. And do this as many times as you can because it's nice to really see where this line is going, especially when you need to find a solution to a system. Okay, now once you've plotted your points, you've got to stop and think. You have to decide what this symbol right here is telling us about this graph. Okay, this symbol is telling us that the line should be dotted because see here, there's no line underneath the symbol. The line should be dotted, and that we should shade in which direction. Okay, so look at the symbol. It's less than, so we should shade down. And I always just remember, okay, that greater than is up and less than is down. So you're going to draw a dotted line. You can use a ruler or do the best you can. Dotted just means there's like little spaces in it. So you have to make sure it's very clearly a dotted line, arrows on the ends, and you're going to shade below. So I always think of this as like pick a point and go below it. Pick a point and go below it. So you're shading all below the line. Now when you have a graphing calculator, the shading will be on there for you. So you'll be able to tell from your graphing calculator which way it should go. All right, so this is y is less than x plus 2. Okay, let's do another one. So I'm going to get my pink pen. And let's do y is greater than or equal to negative 2x minus 1. Okay, so y is alone. We don't have to do that part. So this has a slope of negative 2 over 1 and a y-intercept of negative 1. So we're going to plot negative 1 on the y-axis. And we're going to use the slope to rise negative 2 and run 1. So rise negative 2 and run 1. Rise negative 2 and run 1. Now I'm going to rise positive 2 and run negative 1. Now notice there's a point of intersection here, but with inequalities, the point of intersection actually doesn't matter as much as in an equation. Okay, so I'm rising 2 and running negative 1, and that gives me my line there. Now I have to look at my symbol and decide what that means. And in this case, that means I should have a solid line because there's an equal to, and that I should shade up because it's greater than. Okay, so I need a solid line. I'm going to grab my ruler for this one. I need a nice solid line here. You want to make sure it's very clear whether your line is solid or dotted. Okay, so there's my solid line. And I'm going to shade above the line. So pick a point and go up. Okay, if you just pick points and go up, you can see which side of the line we're shading on here. Okay, make sure it's nice and clearly shaded. You can kind of color it in if you want to. You just have to be careful because you're doing two of them on the same graph. So that's why I like to do kind of the stripes. And I label that, okay? Now, as I said, the point of intersection is actually not an important point here, especially because it's on a dotted line, which means that point is not in fact a solution to the system. It's a solution for the solid line, but it's not for the dotted line. So all I'm going to do here is I'm going to mark my overlapping shaded region with an S. I'm just going to put a big giant S. Now, if you do the stripes like I did here, you're going to see a crisscross pattern, and that's in this section here, okay? If you used like highlighter, it would change the colors, so you would see that. And you'll see on your calculator, it's very clear when you graph it on your calculator. So you're going to put a big giant S in this section. Just make sure you don't actually touch the lines with your S. So you're just going to put a nice S in here so that we can see S for solution. That area is the solution. So any point in that entire section of the graph is a solution, okay? So I want to see if you can come up with a point that's a solution. I'll give you an example. The point 1, 1 right here, this point right here is a solution to this system because it's in the overlapping shaded area. So I want you to come up with a point that is a solution to the system that's not the point I just chose, so not the point 1, 1. Find another point that's a solution to this system, and when the question pops up on the screen, plug in the point that you chose as a solution, okay, so that I can check on that for you. And do not forget that you also have an extra credit assignment and a blue worksheet that are also due next class, so make sure you get those done. Okay, I will see you in class.